All right, let's get into the notes for this lesson here. Before we specifically label today's lesson, I do want you, if you haven't already, to label the unit in your notebook. So we are in a new unit now. We're moving into Unit 6. And we're still talking about the similar theme from last chapter. We are talking about triangles, but specifically we're calling this one triangle congruence. Okay, our goal for this unit is going to be more to talk about how we can show that triangles are congruent to each other rather than all the pieces of information that we just went through last chapter. Okay, so date today is either going to be the 4th or the 8th. Our label for today is just 6.1 congruent triangles, and our objective, like I mentioned, is we're basically just trying to understand what that means when we say congruence, and then be able to use that to prove that two triangles are congruent. And that's going to be a major theme and a major objective for most of this chapter, or most of this unit here. So first off, if we say congruent, what does that mean for two things, shapes, triangles, whatever, to be congruent? Okay, well, congruent polygons are two or more shapes whose corresponding sides and corresponding angles. Okay, so two or more shapes whose corresponding sides and corresponding angles are all congruent to each other. Okay, whose corresponding sides and corresponding angles are all congruent to each other. So we've talked about the word congruence before. It just kind of means the same or the same measure. But now, and we use that with side lengths and with angles. Now specifically we're saying a shape as a whole. So for example here, let's just draw two triangles. We'll keep it simple. Just draw a triangle ABC here and triangle DEF, making them look roughly the same. Okay, and we're saying everything about them, the size and the shape, are all equal to each other. So for example, remember when we're talking about sides and we want to show that they're congruent, on a diagram we mark that with a little dash mark on each line. So for example, I'm going to mark one dash mark on side AB and one dash mark on side DE. And so the reason I do that is I'm showing, okay, these two sides are congruent. Okay, I would need the same thing with the other pairs of sides. So on BC, I'm going to mark it with two dash marks, and same thing with EF. The reason I'm going to mark it with two dash marks is so that I know BC and EF, the two sides with two dash marks on them, those are going to be congruent, but I'm not marking it with one because they're not necessarily congruent to the side lengths we've already marked up. Okay, and then same thing with AC and DF. I want to show that those are congruent to each other, but not necessarily the other ones inside their own triangle. So AC and DF both have three dash marks, so they're congruent to each other, but they're not necessarily congruent to the ones that have two dash marks or one dash mark. Okay, so that's one piece that has to be true about them. They all have to have the same length of sides. And then we said the same thing with the angles. The corresponding angles, or in other words, the angles that are in the same spot, also have to be the same. So to show that in a picture, I just mark it with arcs on the angles. So for instance, angle A and angle D are going to be congruent. So I mark those with one arc because they're in the same spot, or they're corresponding. Angle B and angle E are also in the same spot. So a similar idea, I'm going to mark that with two arcs to show that they are congruent to each other, but not necessarily the ones that I've already shown with A and D. And then lastly, we have one more pair of sides, pair of angles. Okay, angle C and angle F. Those would also be congruent because they are in the same spot, but not necessarily congruent to the rest. So this is what it means if we show that two triangles are congruent. All the pieces, the sides and the angles, are all congruent to each other. Okay, so this is our end goal. All right, with that, one other thing that we need to understand is what we call a congruence statement. Okay, a congruence statement. Okay, and a congruence statement is very important. It tells us which points are corresponding. Okay, which tells us which points are corresponding in congruent shapes. or congruent polygons. It tells us which points are corresponding in congruent shapes. So for using the example that we just had here, okay, I'm actually going to change up the color on my labels here. The congruent statement would look like this. Instead of saying side length, AB is congruent to DE, we're saying the entire triangle. So I'm going to say triangle, and I'm going to label this ABC. So I'm going to go ahead and change up the colors as I go along and write. ABC, okay, is congruent to triangle DEF. Let's go here, E, and then F. I'll explain why I'm changing up the colors on all these here. Okay. So notice this one, it's very easy to see which 2 points are corresponding, or in other words, which 2 points are in the same spot, just by looking at them, because they're oriented the same way. Okay, they're both facing the same direction. However, if I start to rotate or reflect some of these shapes around, it can be even more difficult to figure out which point is supposed to match up with which, if I were to, kind of overlap them or put them on top of one another. Okay, so this is why the congruent statement is so helpful, because it shows me here, if I have A and D, they're both the first letter in my statements, that means A and D are going to be corresponding. And sure enough, we see that is the case in the picture. Okay, same thing here with B and E. B and E are also going to be in the same spot. And then lastly, with our last one that we haven't talked about yet, C and F. C and F are the final letters, so those are also going to be corresponding in my picture. So this statement right here is the one that we want to look for. Because like I mentioned, on some of these examples, it's going to be a little bit tougher to tell which of the points that are supposed to be corresponding. Always look here. Always look at the congruent statement, because that will tell you. The order of the letters is very important. And you'll see that theme as we go through today in our future lessons. Okay? So with this here, let's practice this a little bit. And let's not start off just with triangles, but just with shapes in general. So I want you to take a sec, and I want you to sketch these shapes for me. Okay, so we have these two shapes, PQRS and, how would I name that, GFED. And what we want to do is we want to list all the congruent parts of the polygons first, so making sure that I have all the pieces there. And then if that's the case, I want to create a congruent statement for the two polygons. So if we're looking at listing all the pieces here, we have two types of pieces that we have in shapes. We have sides and we have angles. So first thing I'm going to write down is I'm going to write down sides. Okay, what are the sides that are congruent? Well, if I notice here, if I look at this diagram, I'm going to start off with the sides that have one dash mark. So I notice I have this side and this side that have one dash mark. So what I'm going to say is I'm going to say this side length, PQ, and I'm going to put a little line segment above it, right? That's how we name side lengths. The two endpoints, PQ, is congruent to, and then notice here I have two different ways to name this. I either have FG or I have GF, because those are just the endpoints. It's just switching them around. What I need to notice here is I need to notice which points are supposed to be corresponding, or in other words, I need to order them correctly. So since I mentioned P here first, and this has one angle arc, G would be the point that's corresponding to it, because it also has the angle mark. So if I were to label this FG, that would actually be incorrect. I need to label it in the correct order, because the points should be corresponding. So now if I label this GF, now this works because P corresponds to G and Q to F. Okay, and we're going to continue that here. Okay, so next one, if I'm going around these shapes, I notice I have two sides with two dash marks, so here and here. So if I want to go ahead and label that, the first one doesn't matter. I can label it whatever I want. So we're just going to say SP. So side length SP is congruent to, and now this one again, we need to make sure we label it correctly. So notice G and P always have to be in the same spot when I'm writing them out. So instead of naming this GD, I would need to name this DG. Because again, I need to make sure all the corresponding points are in the same spot when I go to write them. Okay, we'll continue here. Okay, if I say SR next, okay, I notice this next one is actually pretty nice because they all have three dash marks. All the remaining sides, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So we're just going to practice naming all these here. So SR, I'm just going around, corresponds to DE. I'm going to say SR is congruent to DE, which is also congruent to, again, we can go to our last side, RQ, which is congruent to, and again, I'm going to keep the same order and make sure I order them correctly, EF. And notice I don't want to stray from this. I don't want to switch any of these letters around because all these letters are in the correct spot. Okay? So that is with our sides. Next thing I want to do is I want to list the angles that are congruent. So I'm going to go ahead and erase all the marks that I made with the sides. And we're looking at the angles here. Okay, so if I'm looking at the arcs, remember, I notice I see one arc on this angle, angle P. And I know we can either name angles with 1 point or 3. Just to keep things simple for this example, we're just going to name it with 1 point. So I see angle P here is going to be congruent to the angle that also has one arc, angle G, in this polygon. And notice, just like we saw on the sides, P and G are now lining up, or they're corresponding, okay, which is exactly what we want. Okay, continuing here, let's just go in order. So now I see 2 arcs on this angle, so I'm going to say angle Q is congruent to 2 arcs on this angle, angle F. Okay, continuing, going around as well, I see 3 arcs here at angle R, so I'm going to say angle R is congruent to, notice 3 arcs over here, 1, 2, 3, that's angle E. Okay, and then we have one more angle that has 4. I know it's a little bit harder to tell since it's so small, but this would be angle S, which is congruent to the last angle with also 4 arcs, which is angle D. Okay, so this right here tells me all the points that should be corresponding or matching up. P and G, Q and F, R and E, and S and D. Okay, and now we have this here. We listed all the pieces. Now the last thing it said is I want the congruence statement. So I'll go ahead and write this, congruence statement. So now I just need to put it all together and tell which points are corresponding. So the first one here, polygon, is how I'm just going to name it since it's not a triangle. I'm just going to say polygon. And it doesn't matter how you order this first one. Let's just write it in the order that we wrote our angles. So PQRS. We'll say polygon PQRS is congruent to polygon. And then if I'm looking at the other polygon, I need to make sure that I line up all the letters correctly. So for instance, we said P and G always have to be in the same spot. So if P is the first letter, then G is the first letter in the other shape. Same thing, Q and F have to be in the same spot. So I write F next, and then E, and then D. Okay, very important to order these correctly because otherwise I don't know which points are corresponding and I might get confused. So this is why we have the congruence statement. Okay, so that's how we use and that's how we name the different corresponding sides and angles. Okay, so moving on here, using this with some algebra and doing some math here, I want you to take a second. I want you to sketch these 2 triangles for me here. Sketch these 2 triangles. Okay, so we have these here. And I want to find the value of x and y. And notice here, if we don't know which points or angles are supposed to be corresponding, that's why we can always look at the congruence statement. We can say A, B, C, and D, F, E. So we know A matches up with D, B with F, and then C with E here. Okay, so if I'm looking at this and I want to solve for x and y, okay, notice we've talked about this before. I have one expression with x and y both in it, and I don't want to really deal with that yet. Because I can't solve an equation that has 2 variables in it. So I notice I have this other expression here, 8y minus 5. That's relating to this angle here, angle F. And how can I use that, understanding that these shapes are both congruent? Well, I know all the little pieces or the corresponding pieces are congruent. So what did we say earlier? What is the angle that corresponds to F? I don't even need to look at the picture. I just need to look at the order of the letters. That would be angle B. So I see these 2, angle B and angle F, are corresponding, which means they're going to be congruent. So I can say 99 here equals 8y minus 5. Again, I'm using the congruence statement to figure out what are the points that are in the same spot, because sometimes it's not going to be as easy to tell from the picture. Obviously, in this case, it's not too bad. Okay, now we go ahead and solve. So I can go ahead and add 5 to both sides. When I do that, these cancel. I have 99 plus 5, which is 104, and then equals 8y. And then last step here, divide by 8. And we're left with y equals 104 divided by 8. And you can just do this on a calculator if you don't know it. And this is just going to end up being 14 here. Or, I'm sorry, 13. Okay, I wrote it correctly, said it wrong. Okay, y equals 13. Okay, so we have that now. And now the question is, how can we find x? Well, notice we have this expression 2y plus x. We see this side, fe. And just like before, if I want to know what fe lines up with, I can just look at my congruence statement. Fe should line up with BC. So it should line up with this side right here. So I know 2y plus x, or let's order it the way the numbers are written. I'll say 38.4 equals 2y plus x. Both those sides are in the same spot, so they're going to be congruent to each other. And then like we mentioned, I can't solve an equation with two variables in it, but I have found y, so I can go ahead and plug that in. So I'm going to say 38.4 equals 2 times y, or in other words, 2 times 13, like we found, and then plus x. Continue to solve. I have 38.4 equals 2 times 13, which is 26, plus x. And then all I need to do for my last step, if I want to get x by itself, is I just need to subtract 26 from both sides. When I do that, these cancel, leave me with x. And on the other side, I have 38.4 minus 26, which is going to end up giving me 12.4. And in this one, again, we get a decimal. Good habit just to check our work and make sure we did it all correctly if we get a decimal. And in this case, we did. Okay, so this is how you use congruent shapes. All the corresponding parts, all the matching parts are going to be congruent as well. Okay, one other thing we need to talk about today that might help us as we go through and prove that triangles are congruent, because that will be our goal for the future, is a thing that we call the third angles theorem. Okay, the third angles theorem. Okay, and it says this. It says if two angles in one triangle are congruent. Okay, if two angles in one triangle are congruent to two angles in another triangle, then the conclusion that I can come to, or what I can say, is I can say then the third angle, or I'm going to say the third angles of each triangle are going to be congruent as well. Okay, so again, if I look at two triangles and I see two angles in one of them are congruent to two angles in the other, even though I'm not given information about the third angles, I know that they are going to be congruent. So for example here, we just draw two of these here. Let's say, for instance, we have, keep it simple, let's say we have 100 and we have 30 here. 100 degrees and 30 degrees. And then let's say we have the same thing over here. We have another triangle with two congruent measures as well, 130 as well. What that means is I don't even necessarily need to know what each of these angles are. Okay, I would be able to know what they are in this case. But what that means is that these two angles here would have to be congruent as well. Okay, and that's helpful because that's going to help us as we try to prove different things about triangles. Okay, so last example here, practicing this a little bit. This is going to be similar to what the problems are going to look like as we move forward in this unit. So example 3 here, given this diagram, I want you to prove that triangle DEF is congruent to triangle GEF here. Okay, DEF is congruent to GEF. Okay, so if I wanted to prove this, usually what I could do is I could set up my two columns and I could go through my process of statements and reasons, and we're going to see that a lot in this unit. But just to save us from that today, right now all we're going to do is we're just going to list out all the congruent parts that we know. So for example, let's start with the sides here. And let's start with the sides that we know are congruent. Well, notice here I have one dash mark here and one dash mark here. So I know those are congruent. So I'm going to say side length, DE, is congruent to, and then remember I need to order them correctly. So D is supposed to correspond to G, and then E to itself. So DE is congruent to GE. I want to make sure I order that correctly. I don't want to switch that around. Okay, what are other sides that I know? Well, I see two dash marks here and two dash marks here. So same idea. I also know DF is congruent to and again, we need to make sure we order it correctly. That is GF. Okay, DF is congruent to GF. So I have two sets of sides, and to prove that these triangles are congruent, I have to show all the pieces. So I have two sets of sides. I need the third pair of sides, and notice we actually do have the third pair of sides right here is just EF, and it's actually EF in both of them because it's in both of the triangles. So what I know is that EF is the same side, so of course it's going to be congruent to itself. So I could say EF from one triangle is going to be congruent to EF of the other triangle. Okay, and we'll talk about this more, but this actually goes back to a property that we talked about last semester. Okay, so we'll get more into that, and I'll explain more of that later on. Okay, but otherwise we have all three pairs of sides here. Two of them are marked, and then one of them we know just by looking at it. All right, and then we need to also prove the same thing with the angles if I'm going to prove the triangles as a whole are congruent. Because remember, all of the little pieces, not just some of them, but all of them have to be congruent. So for example, if I'm looking at the angles here, I notice I have one arc on each of these. So I'm going to label these here. I'm going to say angle, and I want to mark it with the 3 points that make up that angle. So angle DFE, just that portion, is congruent to, and the same idea on the other side, making sure I order the letters correctly, GFE. So DFE is congruent to angle GFE. Okay? So next pair of angles that I know here, I know angle D and angle G are congruent because they both have two arcs. So I'm going to say angle D is congruent to angle G. And if we wanted to, we could label it with 3 letters. But in this case, there's only one angle at each of those points, so I'll just label it with 1. With F, we could not do that, so we had to label it with 3. All right, and then lastly, this last pair of angles, it's not marked for us over here, but remember, we would know that they're congruent because of the theorem that we just talked about. We said if we know 2 angles from one triangle are congruent to 2 angles of another triangle, then the third angles are going to have to be congruent as well. So I could say angle DEF is congruent to angle GEF. So again, just taking out the portions from the left and from the right. Angle DEF is going to be congruent to angle GEF. And now I've shown that all the pieces are congruent. Okay, that's marked, that's marked. We know that. That is marked, and then we know that by the the third angles theorem. Okay, so now that we have all the pieces, what we can say is we can say triangle DEF is congruent to triangle GEF. Okay, so this was more of an informal proof, and we'll work on more specific ones in the future. Okay, but otherwise, that is the notes for today. Okay, rest of the time, you'll have the assignment for today. I don't know for sure if we're going to do an exit ticket or homework assignment, but as of right now, let's just say 6.1 exit ticket. And if you're in class, that will be handed to you. And then if you are online right now, then that should just be posted on the class website if you want to get that done. Okay, but otherwise, if you have any questions, feel free to let me know. All right, thanks, guys.